Yes. So we'll continue permutations combinations. Okay. So we have seen end rule and R rule, and we have solved few questions how to arrange the numbers. Okay. So now now we'll try to solve the arrange the people. Okay. We need to arrange the people in a row. As started already arranging people in a row is also very much like forming a numbers, because for a maths it is hardly make any difference if you are placing digits in place or persons in positions. The only difference being that instead of conditions like numbers being even or divisible t rules, even a number and divisible by 3, we could have different conditions like two or more people wanting to together or not wanting to together or being in alternate positions. These are the conditions will come. That's the only difference. Otherwise it's again the same funda. So here what we are looking at here is we are talking about arranging in a row. We are arranging the people. Okay, we are arranging what, guys? We are arranging what? People. Okay, in a row. Okay, so let's start with a question. We'll start with a question. Write down a question. Okay, in how many ways can 6 people arranged in a row? 6 people arranged in a row when 2 of them are adamant about standing at either extreme positions. Okay. So whenever you are doing the questions, first you need to what? The conditions are important. Okay, the conditions are very, very important. As learned earlier, we should satisfy the given conditions first. Yeah. Total how many people are there? Let's say there are total 6 people arranged in a row. 2 of them are adamant about standing at their either extreme positions, which means that 2 people, say A and B, can be placed at extreme ends in 2 ways. No, let's say there are, how many persons are there? 1 2 3 4 5 and 6. Here A will come, here B will come, or here B will come, or here A will come. Yes or no? So let's say already these places are fixed. This is one way, this is also one way. Out of, let's say, A, B, C, D, E and F, there are 4 persons. A and B are fixed. So remaining how many places are vacant? 4 places are vacant. Extra, yes or no? So 4 places and 4 people. So can I say this is 4 ways, this is 3 ways, this is 2 ways, this is 1 way, which means 4 places, 4 ways. You can say 4 factorial ways. Here also this is 1 way, this is also 1 way. So you can say again, sorry, there is a gap of 4 ways, 4 factorial ways, which means this way or this way will come into the picture. So what is 4 factorial, guys? 24. R means plus, again 4 factorial, which means what? 24. So 24 plus 24, that will give you what? 48 ways. Okay, 48 ways. The total number of arranging, because A will come the left end, B will come the right end, or B will come the left end, A will come the right end. So 2 places definitely I am going to fix. So I can say that is 1 way and 1 way. Remaining 4 places are vacant, 4 persons are there. So 4 factorial ways. Okay, when there are 4 factorial ways, so 4 factorial, 4 ways, 3 ways, 2 ways, 1 way, that means nothing but 4 into 3 into 2 into 1, which means 4 factorial. So 4 factorial is nothing but what, guys? 24. So 24 ways and If I start with A 24, if I start with B, more 24. So 24 plus 24 is what? Okay, sorry, 24 plus 24 is what? 48 ways. Or you can say 2 into 24. Okay, so that will give you 48 ways. That will give you what, guys? 48 ways. Okay, 48 place. Okay, same question, but we'll change, few conditions here. Let's say this is a condition, in how many ways can 6 people can be arranged in a row when 2 of them are adamant about standing at the either extreme positions, okay, and other 2 persons are, you know other 2 persons are adamant about standing in the middle. Okay, standing in the middle. Okay, standing in the middle. Guys, look at here. The 2 persons who want to extreme ends can placed in 2 ways. Okay. Similarly, the person who want to be in the middle can be 2 ways. We left with how many members? Obviously, we left with how many members, guys? We left with only 2 members. No, yes or no? We left with only 2 members. So 2 places, 2 vacant places. That you can say 2 into 2 into 2. That will give you what? 8 ways. That will give you what, guys? 8 ways. Okay, so this is the these type of questions will come. So whenever you come across these type of questions, how the questions you need to do. Okay, sometimes they'll give conditions like people, the persons to be together. Let's understand with an example. There are 7 people who have arranged in a row, and out of there are 7 friends. Okay, 7 friends. Out of 7 friends, I want to arrange them in a row. There are 7 different places. In these 7 members, A, B, C, they want to be together. 3 people want to be together. A, B, C, maybe B, C, A, maybe C, A, B. Anything may be possible. Okay, together. When this is the condition, in how many ways, the arrangement be done. Okay, then how many ways the arrangement be done. Okay, whenever you come across, these type of situations, look at here, guys. Guys, since, the 3 person cannot be separated, when 3 persons, whenever, they'll say there are a bunch of persons be together. So I cannot separate them any cost. So whenever 3 are there, consider them as one. You have to consider them as what? One quantity. So, all the 3 with, let's say there are 3 people, A, B, C, tie them up with a row. Okay, so A, B, C. Are you getting my point? So out of 7, this is 1. Okay, so remaining would be what? D, E, F, and what? G. Okay, 1, 2, 3, 4, 5. So there are total how many persons are there? Because I treated ABC as one entity. Let's say there are 7 friends. Okay, A, B, C are the 3 friends, D, E, F, G, and the other 4 friends. When they are always together, I treated them as what? One entity. So 4 plus 1 is what, guys? 5. Okay, 4 plus 1 is what? 5 persons. Okay, so consider this group as 1 person when placing them in a row. So now we have to arrange whom? This 4 and Y, we have to arrange them what? 4 plus 1, 5 persons in a row. Which can be done, 5 persons and 5 places. Okay, because these persons will take 3 places, but I assumed what? 5. So 5p5, that will give you what? 5 factorial. What do you mean by 5 factorial? 120 ways. Okay, 5 factorial means what? 120 ways. Yes or no? But for each of 120 ways, the 3 persons which, because A B C is one way, B C A is one way, C A B is one way. So I can write A C B also no. I can write B A C also no. I can write C D A also no. Yes or no? So further there are 6 different arrangements will come. So among themselves I can arrange in how many? 3 factorial ways. Okay, I can arrange them in how many? 3 factorial ways. Are you getting my point? I can arrange them in how many? 3 factorial ways. So there are 120 ways. For 120 ways, okay, the 3 persons, which are considered as one can be further arranged among themselves, give a rise to different of each 120 arrangements. There are further, because 3 person arrange themselves in how many ways? 3 factorial ways, which means for every 120 ways, and further there are 3 factorial ways. So 120 into 3 factorial means what? 6. So 12 6 is 72 and a 0, so that will give you 720. That will give you what, guys? 720. Whenever the approach, when they are, always remember, when they are together, this is a standard model. When they are together, please think like this: the way to proceed is to be considered all those who have to be together as one object, and go ahead with the overall arrangements, which means the one objects and the remaining one. Okay, arranging this one object and the other who are not particular about their positions. Now, for each of these arrangements, further arrange those who insist on being together among themselves. Okay, let's say, let me take one more example. Now let's say there are 8 persons. 3 persons want to be together. Okay, 3 persons want to be together. So tie them 3 persons. So A, B, C is one entity. D, E, F, G, H. So this is 5 and this is 1. Total is what, guys? 6. Okay, total is what? 6. Okay, so that is nothing but 6p6. That will give you 6 factorial. What is 6 5? 1 into 2 into 3 into 4 into 5. Okay, and 6. Okay, so 6 factorial means 120 into 6, 720. Okay, 720 into further 3 factorial, so into 6. So this is how you are going to get your answers. Okay, this is how you are going to get your answers. Okay, okay. So we'll take few examples to get good understanding on this particular topic. We'll take up few more examples, so we'll be ready with the stuff. Okay, right. If this is a condition, there are 4 boys and 4 girls to be arranged in a row. There are 4 boys and 4 girls to be arranged in a row. Okay, if all the 4 girls have to be together, okay, if all the 4 girls have to be together, in how many ways the arrangement to be done? Okay, in how many ways the arrangement to be done? Okay, guys, look at here. There are 4 girls and 4 boys. The condition is what? All girls are together. All girls are what? Together. Okay, when all girls are together, okay, when all girls are together, it's going to be what? I can say girl is 1 unit and boys is 4. So 1 unit plus 4, I can say there is 5 factorial, no? Yes or no? So there is a 5 factorial, but the point is what? Among themselves, girl, you can arrange them in how many ways? Again, 4 factorial ways. Yes or no? So, consider all the girls as 1 unit. So we have to arrange 5 units in 5 places. Okay, and this can be done in how many ways? 5 factorial ways. Now one of the units is of 4 girls, who can arrange among themselves in 4 factorial ways. Those, the total number of ways you can say it as 5 factorial. Among the girls you can say 4 factorial. So 5 factorial into 4 factorial is going to be your answer. Okay, 4 factorial into 5 factorial is going to be your answer. Okay, okay, that's how you can end your answer. Let's try to arrange few more people. Okay, please write down, please write down. In a group of 10 people, 4 speak on French, 3 speak only Spanish, and the rest speak both French and Spanish. The rest speak both French and Spanish. In how many ways can 10 people be arranged in a row such that all those who speak only French are together? Okay, who speak only French are together, and so are all those who speak only Spanish. Okay, so the question is what? In how many ways can 10 people be arranged in a row such that all those who speak only French are together, and so are all those who speak only Spanish? Okay, who speak only what, guys? Spanish. So whenever when you come across this type of situation, let's consider, for who speaks only French. Consider for who speaks only French as one unit. Okay, the people who are speaking French, they are 4. Consider them as one unit. 3 who speak Spanish, consider them as one unit. Okay, so rest of whom 7 gone, so I left with 3. So this is French, this is Spanish, and this is what? Okay, both. This is French and Spanish. Consider them as one unit. One unit. So you can say one unit, one unit. So we have only French and only, these are 3 units. So because I cannot take this as one unit, so 1 plus 1 plus 3. So total 5 objects. Okay, 5 objects. Yes or no? So 5 objects, that can be what? 5 factorial ways. Obvious, because 4 are speaking French, 1 unit, Spanish 1 unit. Together 1 plus 1 plus 1, 5. So 5 members, 5 ways, that will give you 5 factorial ways. Okay. Now for each of the above 5 factorial arrangements, the 4, obvious, no? The 4 among themselves, that will give you 4 factorial for the French. For the Spanish, you can say 3 factorial. Are you getting my point? So the total number of arrangements will come 5 factorial into 4 factorial into 3 factorial. Okay, 5 factorial into 4 factorial into 3 factorial will come. Okay, so how 5 factorial? So for 4 French speaking persons can be arranged among themselves in 4 factorial ways. Those the total number of ways in which 10 people can be arranged. Consider the 3 who speak only Spanish, which is 5 factorial into 4 factorial. Now again, this 5 factorial into 4 factorial arrangements, the 3 who are speaking, Spanish can be arranged themselves, which is 3 factorial. So you can say 5 factorial into 4 factorial into 3 factorial. That's how you can arrange, 10 group of people, okay, who are speaking French, Spanish, and French and Spanish together. So 5 factorial into 4 factorial into 4 factorial. Okay. Excuse me. Okay, guys, till now we have seen, when persons are together. Okay, now we'll see when the persons are not together. Okay, when the persons are not together, how we are going to see. Okay, again let's understand this case example. We have seen, there are 6 boys and 4 girls to be arranged in a row. No 2 girls stand together. Please write down this question. There are 6 boys and 4 girls to be arranged in a row. In a row. Okay, in a row. In a row. If no 2 girls should stand together, in how many ways can the arrangement be done? In how many ways can the arrangement be done? Okay, done. Whenever people are doing, this question, yeah, in this question, where no 2 units should be together, we should first arrange the other units. So whenever no 2 girls are together, so we need to arrange them whom? Boys. Okay, we need to arrange them whom? Boys. So how many boys are there? Yeah, boy 1, boy 2, boy 3, boy 4, boy 5, boy 6. 6 boys will make how many spaces? 7 spaces. So boys can be arranged in 6 factorial ways. So no 2 girls together. Girl 1, girl 2, girl 3, girl 4, girl 5. You can write girl 6 also here. Did he mention boys will not be together? No. So you can write girl 6 also here. You come across 2 conditions. Yes or no? Are you getting my point? But you need to understand there is only 4 girls. There is not, yeah. So when there are 4 girls, 4 or 5 girls, yeah, when there are 4 girls, okay. So the point here is this. So whenever, how many spaces they are making? 7 spaces. It is ensured that, no 2 girls will be together, but we have 7 spaces, and only there are 5 girls. Yes or no? It means what you need to understand. It just means, that 2 of the spaces will be vacant. The empty space would mean by boy will be adjacent, which is acceptable. No, it's nothing but, nothing is mentioned about the boys. Yes or no? Being or not being together. Those 5 girls to be placed in 7 different available spaces. That can be 7 places available, but there is only 5 girls. Okay, let's say there are 7 boys and 5 girls. Okay, so 7p, for which means 7 into 6 into, okay, 5 into 4. Okay, so that will give you 6 factorial. So girls, I can arrange them 7 into 6 into 5 into 4. Okay, 7 into 6 into 5 into 4. Okay, so please be conscious while solving the questions. Okay, while solving the questions, arranging people, somewhat different kind of stuff, but that is easy. Okay, that is very easy. Okay, now Now we'll try to understand one more question. Okay, so please write down the question. Please write down the question. So first you need to understand. So first arrange the boys, then arrange the girls. Okay, don't arrange girls first. Okay, yeah. Next, there are 4 boys and 4 girls to be arranged in a row. Okay, 4 girls and 4 boys arranged in a row. If no 2 girls should stand together, okay, no 2 girls, okay, no 2 girls stand together, in how many ways can the arrangement be done? Okay, okay, so whenever you come across, this type of situation, your approach should be like this. When, no two should be together, first, ignore all the objects of which no two should be together. In this particular question, who should not be together? So girls should not be together. So ignore them. Who is the remaining persons? Boys. So first arrange the boys. Okay, so arrange the rest of the objects, which means so first arrange the boys. Okay, now arrange the boys. Okay, when you arrange the boys, guys, the point is this. Now place the objects of which no two should be together in the gap of between any 2 objects of the earlier arrangements. Yes or no? So can I say the 4 boys first can be arranged in 4 factorial ways? Of course. Yes or no? 1, 2, 3, 4. So 4 boys will make how many spaces? 5 spaces. Yes or no? So 4 boys how many ways? 4 factorial ways. And there is girls also, no? Yes or no? For every girl there are 5 spaces vacant. So yes or no? 5 into 4 into 3 into 2. Okay, 5 into 4 into 3 into 2. So that will give you 4 factorial into, this is almost 5 factorial. So you can say I am not going to calculate this. So answer is what? 4 factorial into 5 into 4 into 3. Why 5 into 4 into 3? Because 5 places for the 4 girls, they could be arranged in, for the girl one, there are 5 places vacant. 5 ways she can occupy her position, no? So that's why. So for the next girl, 4 positions. The next girl, 3. Next girl, 2. That's how, you can end your answer. It does. Don't say it's a 4 factorial into 5 factorial. No. 4 boys will create 5 places. So that's why boys can be arranged in 4 factorial ways and the girls can be arranged in 5 into 4 into 3 into 2. Okay, 5 into 4 into 3 into 2. So whenever you come across this type of situation, so first arrange. Say no boys together means arrange girls first. No boys together means arrange whom first? Yeah, the boys first. I hope you got it. Okay, so this is how, when the persons are not together. Now we'll try to understand, when the persons are alternate. When the persons are alternate. Yeah, please write down. There are 4 boys and 4 girls to be arranged in a row. Arranged in a row. If girls and boys have to be alternate. Okay, alternate. In how many ways? In how many ways the arrangement? In how many ways can the arrangement be done? Okay, in how many ways the arrangement be done? Guys, when there are 4 boys and 4 girls, you can take any of them. So let me start with girl. So next whom should come? Boy. Next girl. Next boy. Girl, boy, girl, boy. So can I say 4 girls? 1, 2, 3, 4. 4 boys. 1, 2, 3 and 4. So they are alternate. Yes. So why are you only are starting with girl? Why can't you start with boy? Boy, girl, boy, girl, boy, girl, and boy, girl. So whenever there are alternate positions, okay, whenever there are, so boys you can write 4 factorial and girls also 4 factorial. This arrangement can be done twice, no? So that is nothing but 2 into 4 factorial into 4 factorial. So 2 into 4 factorial into 4 factorial. So we have seen when they are alternate together, okay, when they are alternate together, and we have seen condition for persons not being together, okay, we have seen condition for persons being together. So in when we are let me summarize this. Arranging, okay, arranging people in a row, we have seen three different type of sets. Persons, okay, to be together, okay, and this is one variety. What is the other variety? Yeah, persons not to be together, okay, persons not being together, okay, not being together. And finally we have seen what? Yeah, when the persons to be, so, these are the conditions, okay, these are the conditions, guys, okay, these are the conditions. Persons to be together, persons not to be together, and when they are alternate, when they are alternate, these three kind of questions you will come across, okay, you will come across, okay, you will come across. Are you getting my point? So whenever the approach for having together, okay, so whenever they are together, assume who are together, assume to be the standard approach, one unit. So the way to proceed to consider all the things who have to be together, consider to be one unit, one object, and go ahead with the overall arrangements, okay. Now for each of these arrangements, further arrange those who insist on being together among themselves, okay. Next, when they are not being together, what is the position? So arrange who are not being together, arrange the rest, the remaining ones, okay. Arrange the, ignore all the objects of which no two should be together. Arrange the rest of the objects the first, okay. Then the remaining will come into the picture. When they are alternate, your wish. You can arrange boys first, or you can arrange girls first. You can get your answer. Okay, you can get your answer. Till now we have seen the arrangement of numbers, the arrangement of people. Now we'll go for circular arrangement. Okay, now we'll go for circular arrangement. Till now we have seen the linear arrangement. Then how the circular arrangement will come into the picture? Circular arrangement, the arrangement that have characteristics of both linear and circular arrangement. Circular arrangement, distinct form of linear arrangement, and the method used to be taken, tackle them to, it's also different, okay. Guys, arrangements are relative positioning among themselves. Let's say consider the following. There are two linear arrangements. Let's say so now we are talking about circular arrangements, okay. Circular arrangements, okay. We are talking about circular arrangements, okay. Circular arrangements, yeah. And let's say if you consider A, B, C, D, and you can say D, C, B, A, these are what? Two linear arrangements. Are they two different or same? Yeah, in the above, in these particular examples, we have treated them as different, and they are different. But the fact is that, each of the objects have the same neighbors. Yes or no? Because, one time the end is occupied by A or D did not make did not make them same. While, the neighbors are same, their order has changed. In the first arrangement, B has A to its right, and in the second arrangement, B has A to its left. Okay, similarly in first arrangement, A is to the left of the one left end of the row, whereas the second A is to be right end of the row. In other words, the first arrangement is, no one to A's right, but in the second arrangement, A has, C to its right. So the point is this, friends. Okay, this make, the arrangement different. Okay, arrangement different. So you can consider A B scenario. You can write, A B C D, D A B C, C D A B, B C D A. They move again. We would arrive back the original arrangement, A B C D. It is obvious that obviously all the four arrangements are different, because different people occupy the extreme ends. So the numerous other different related to right and left of each individual. Consider the same event happening in a circular arrangement. Let's look at here. The same event is happening in a circular arrangement. A, B, C, D. D, A, B, C. This is circle. And this is arranging in circle. C, D, A, B. Here A, B, C, D. This whenever it is arranged in a circle, okay, whenever it is arranged in a circle, okay, each of the four ways in a circular arrangement is same. Okay, A, B, C, D, A, B, C, D, A, B, C, D. Because, if you talk about A, B, C, D, A, B, C, D, A, B, C, D, A, B, C, D. That's the difference between, the circular arrangement and linear arrangement. In a linear arrangement, what we have seen, guys, A, B, C, D, here, D, A, B, C, here, C, D, A, B, here, B, C, A, D. So the point is this, here their extreme ends are totally different. You cannot say where is the extreme end. Okay, where is the extreme end, in circular arrangement, in every aspect among themselves. Okay, so not only does each individual have the same neighbor, but also the order of neighbors is also same. Okay, because if you took A neighbor is D and B, in case of, if you take any case, A neighbor is, okay, A neighbor is home, obviously B and D only. Okay, are you getting my point? Okay, so in all the four arrangement, B has A to its right and C to its left. Okay, so the fact that the four positions is taken by different individual in four possibilities, to resorting an external reference of north. Okay, so the point here is this. Whenever you come across, there are four different Because circular arrangement is definitely distinct form of linear arrangement. Let's take an example to understand the approach to solve a circular arrangement question. In how many ways? Let's write down a question. Let's write down a question to understand a circular arrangement. In how many ways can four people be seated around a circular table? Okay, around a circular table with four chairs. With four chairs. Okay, four people are there. Let's take this is one chair, the other chair, the next chair, and the next chair. They are in circular arrangement. Okay, they are in circular arrangement. Imagine, you are the first person to be given privilege to choose any position. In how many ways can you select the position you want to sit in? Most of the often the answer is 4. Think again. If you are still stuck with 4 as your answer, try to find out difference between the two different approaches. Look at here. So let's take here is the one person. Okay, here is one person. Okay, let me take the another diagram. Let's take here is one more person. Okay, without resorting to an external reference, both ways are the same, right? Yes or no? It's obvious, no? Both ways are the same. Imagine you are the alone, on a circular table of 4 chairs. There is no external reference. If you move from one chair to other, for you the table will appear extremely the same. Yes or no? In fact, which of the 4 chairs, okay, the first occupant sits, all of them in the same, okay, so the first can choose his position in only one way. Okay, so don't say there are 4 ways. You can say there is only one way you can sit there, which means, guys, please understand this point. In fact, whichever of the 4 chairs, the first who is occupying the chair, of them sit the same. Anyway, it look like same. Those, the first who are sitting, they can choose his position in only one way. With the first person choosing one seat in one way, the second person who has 3 different ways. Yes or no? So here the point is, the first person, he doesn't have 4 ways. He can choose only one way. Okay, so the second person has 3 ways. Could sit opposite to the first person, left to the first person, or right to the first person. Those, the second person can choose his position in how many ways? 3 ways. Okay, so the third person can choose how many ways? 2 ways. So the last person can choose how many ways? 4 ways. So that means 1 into 3 into 2 into 1, that means 3 factorial. That means what, guys? 3 factorial. Okay, that means what? 3 factorial. Okay, let's say, so answer for this question is what? 3 factorial. Let's say 8 people. Okay, now 8 chairs. So the first person will be 1 only. For the next person, 7, 6, 5, 4, 3, 2 and 1. That is nothing but 7 factorial. So when there are 8 chairs, the ways is 7 factorial. When there are 4 chairs, the chairs will be 3 factorial. So when there are n chairs, so how many ways? n minus 1 factorial ways. Okay, n minus 1 factorial ways. So the generalization is what, guys? In general we can say n people can be seated across a circular table in n minus 1 factorial ways. Okay, n minus 1 factorial ways. Okay, n minus 1 factorial ways. Okay, so that's how you can end your answer. Okay, that's how you can end your answer. Okay, so we'll try to solve few questions. Okay, why we are using n minus 1 factorial? Yes, guys, listen. Whenever there are in circular table, okay, in circular arrangement, for the first person, he cannot choose four ways. He can choose only one way. After the one way, the remaining positions will be decided. Okay, remaining positions will be decided. Yeah, please take down one example. Four boys and four girls have to be selected, have to be seated around a circular table such that such that such that no two girls are adjacent to together, no two girls are adjacent to each other. In how many ways, in how many ways can they be seated? In how many ways can they be seated? Since it's a circular table, no two girls are adjacent to each other, they have to be alternate chairs, and the remaining set of alternate chairs will be occupied by the boys. So now four boys seated in four alternate chairs in circular arrangement in how many ways? 3 factorial. Just now I told you. So first I need to select boys. So how many ways they will sit? 3 factorial ways they will sit. After sitting boys 3 factorial ways, okay, so boys are 4. So girls are what? 4. So girls have how many places vacant? The remaining places are vacant. So that is nothing but, you know, with the boys seated, there are 4 chairs of the girls, and there is already a reference created because of the boys seating. The 4 girls can be seated in 4 chairs in 4 factorial ways. Those I can say the total number of ways is 3 factorial into 4 factorial. 3 factorial into 4 factorial. Okay, 3 factorial into 4 factorial. This is how the arrangements of uh, the particular circular arrangement will come into the picture. If there are n persons, in how many ways they will arrange? N minus 1 factorial ways they arrange. Now the arrangements of objects, with few identical. Okay, with few identical. I know everybody know this particular method. I no need to explain this. Yeah. Let's say there is a word called we'll take one simple word, nature. Nature. In how many ways can the letter arrange the alphabets of a word? How arrange the alphabets arranged among themselves? Whenever you come across this type of particular situation, okay, so how many letters are there? 1, 2, 3, 4, 5, 6. So you can say directly this answer is what? 6 factorial. But you need to understand, when nature is very clear, there are 6 different alphabets. But if I say revenue, NUE, so first count the number of letters. 1, 2, 3, 4, 5, 6, 7. So 7 factorial by, out of this, is there any repetitions? Yes. How many E's are there? 3 E's. So that is nothing but 7 factorial by 3 factorial. Okay, 7 factorial by 3 factorial. So whenever you come across, okay, arrange the objects when few of them are alike. When they are different, it's okay. Directly, there are different n numbers, n positions, and factorial ways. But arrange the objects when few of them are alike. Okay, few of them are alike. The total number of ways arranging n objects. Okay, some m identical different ways. Simple. Revenue is there. So 7 factorial by 3 factorial. We'll try to calculate few of the questions you will understand. Let's say Mississippi is there. Mississippi. Look at here how messy is Mississippi. Yeah, yeah, I understand it's a Mississippi. So first count the number of letters 1 2 3 4 5 6 7 8 9 10 11. So this is step number 1. So write in the numerator 11 factorial. In the denominator repetitions, I, how many times I will come? 1 2 3 4 times. S, how many times it will want? 1 2 3 4. P, how many times it will come? 2 times. So 11 factorial by 4 factorial into 4 factorial into 2 factorial. That's it. So this is how you can arrange the number of what? Number of words. Okay, number of words. Okay, sometimes they may ask you like this. Sometimes they may ask you like this. How many ways? Please write down a question. How many ways? How many ways can the letter of the word? Okay, letter of the word opposition. Opposition. SITIO, opposition can be arranged so that three O's and S are together. Three O's and S are together. So whenever you come across O's and S are together, so first three O's and S, when they are together, tie them up. Assume it's a one unit. When this is gone, so I left with P, I, T, I and N. So these are what? 6. So total is what? 7 factorial. Yes or no? Total is what? 7 factorial. Out of this, 2 P's are repeating and 2 I's are repeating. Yes or no? 2 I's are repeating. Is this your question is done? No, your question is not yet done. And into OOSS. So total how many are there? So the group of 3 O's and 1 S, they are arranged among themselves. No, so that is nothing but 4 factorial. By how many are repeating? 3 O's are repeating, which means 3 factorial. So now you can say the total number of arrangements will be the 7 factorial by 2 factorial into 2 factorial by 4 factorial into 3 factorial. So first, whenever there is a condition, first respect the condition. What is the condition? 3 O's and S should be together. Treat them as one unit. Write the remaining ones. That could be 6. So 6 factorial, 6 plus 1, 7 factorial. That should be divided with what? 2 factorial into 2 factorial. Why 2 factorial? Because 2 P's are there, 2 I's are there. That is not the end of the answer. And in 3 O's and 1 S, that is also having what, guys? Yeah, so 4 factorial by divided by 3 factorial. Okay, so that's how you can end your answer. Okay, that's how you can end your answer. Okay, yeah. This is how you can arrange the number of, okay, you can arrange the number of words. Okay, letters in a letter, and how many ways you can arrange your words is going to be there. Okay. Okay, now we have seen all the arrangement stuff till now. Okay, now we'll see, guys, now we'll see the selection part. Okay, now we'll see the selection part. Okay, how the selection will come into the picture. So we have seen the permutation thing now. So next we'll see the combination. Okay, next we'll see the combination. Okay, what is the combination? Yeah, combination is nothing but what? Selection. Okay, combination is nothing but what, guys? Selection. You know, as far our task was always arrange the objects to place them in a specific order among themselves. Sometimes we would be interested in only selecting few objects out of the given objects. In this case we just need to select, and we need not to arrange them in an order. Example, we need to select 4 students out of 15 students who will present the college in a quiz competition. Okay, or we need to form an academic committee of 3 professors from 10 professors. In this case, who is first, who is selected second, and so on doesn't matter. The word first and second implies an ordering. What matter in this case of selection is the composition of the final group. It doesn't matter who is coming first, who is coming second. Out of 10 you are selecting what? You are selecting 4. The group is important. Okay, the group is important. Let's compare what is the arrangement and what is the selection. Okay, say we have to arrange 3 people out of A, B, C, D and E in a row. Okay, we have to arrange them out of 3, like A, B, C, D, E in a particular row. The arrangement may be A, B, C, A, C, B, are what the distinct arrangements because of the relative positioning among themselves. Yes or no? However, if we had to select the 3 people out of 5, both of these arrangements would be the same of selecting. Okay, if the group of ABC. So the point is this: in fact, all the arrangements that are possible with ABC, in case of selection, we would count only one selection, since ABC be arranged among themselves, which is 3 factorial. Okay, 6 ways. All the 6 ways would be continued as only one if they are in the case of selection. Okay, and not an arrangement. Okay, not an arrangement. Okay, a selection different from ABC would be only when the group of composition is different. Say ABD or ACE or CDE, etc. So these are also group. Okay, these are also what, guys? Group. Okay, we'll understand number of ways of selecting. Consider some 3 people out of ABC. Okay, guys, let me write here how the 3 people out of ABC. The selection must be ABC, ACB, okay, BAC, BCA, CAB. So can I say one way, second, third, fourth and fifth? It's going to further, yes or no? So that is nothing but 5 into 4 into 3. that will give you 60. Okay, that will give you 60. But the number of selection, the number of arrangements are 60. The number of selection, the total ways, 60 factorial, 60 ways by 3 factorial. Okay, 60 ways by 3 factorial. Okay, so select 3 people out of 5. Now arrange 3 selected people among themselves. Okay, since we know that the number of ways in which 3 people selected to be arranged among themselves is 3 factorial. So the point is this. So finally I am concluding this particular point. Okay, so number of selections into 3 factorial will give you the number of arrangements. Okay, the number of arrangements, which means, so from this you can say number of selections equals to number of arrangements divided by 3 factor only, no. Okay, so I want to define, if I want to define NCR, which means NPR by R factor only, no. Yes or no? Yes or no? So we already know NPR, which means what? N factorial by N minus R factorial. Okay, so you can write here as N factorial by N minus R factorial into R factorial. So this will give you NCR. So NCR, you can write it as what? N factorial by N minus R factorial into R factorial. Okay, NCR, which means what? N factorial by N minus R factorial into R factorial. For your better understanding, let me write 15C4, which means what? Yeah, so 15 into 14 into 13 into 12 by 1 into 2 into 3 into 4, or you can write this as 10 if you want. 10C3, 10 into 9 into 8 by 1 into 2 into 3. Okay, you can say NC 1 is equals to N, NC N is equals to 1. Okay, NC N is equals to 1, or you can say NCR is equals to NCN minus R, both are same. Okay, NCR is equals to what? NCN minus R. Okay, so NCN minus R, or you can say, so both are same. So for that also you can write like this, NCN minus R, which means N factorial by N minus R factorial into R factorial, which is also equals to NCR. Okay, which is also equals to NCR. Okay, NCR. We have to select 20 people from a group of 5 people. How these two are same. Let's try to understand like this. We have to select 20 people from a group of 25. Out of 25 we need to select 20. Rather than calling out of the names of 20 people who are selected, it's easy to call 5 people. No, it's easy to call 5 people, right? Yes or no? So it's easier to call out of the names of 5 people who are not selected. So every possible way of selecting 20 has the unique group of 5 people also not selected. Okay, so that is nothing but, So instead of writing 25C20, which is also equals to 25C5. So that is nothing but how this will come, 25C 25 minus 20. So that is nothing but NCR is equals to NCN minus R. Okay, NCN minus R. Okay, so this is how the selection. So whenever the selection, okay, whenever the selection will come into the picture, C means combination, permutation, arrangement. Okay, okay. So let's take out few examples. Out of 5 men and 6 women in a row, how many ways can a committee of out of 5 men and 6 women in a out of 5 men and 6 women, in how many ways can a committee of 2 men and 3 women can be selected? Yeah. Okay, so guys, look at here, 2 men can be selected out of 5. I need to select, so can I say 5C2? Yes or no? Out of 6 I need to select what? 3 women, no? So I can say 6C3. Yes or no? So and is the conjunction, which means which term will come? So 5C2 into 6C3, which means 5 into 4 by 2 factorial into 6 into 5 into 4 by 3 factorial. So if you calculate this, 2, 6 means 20 will left. So 10 into 20, that will give you 200 ways. Okay, 200 ways. A very simple one. 5 men select 2 men, out of 6 women select 3 women, because I want a committee of 5. Okay, so 5C2 into 6C3. So calculate that, you will get your answer. Calculate that, you can get your answer. Okay, so this is all about the selecting a number of men and women. Let's try to solve one more question, so that you will have a clarity. Write down. Out of 5 men and 6 women in how many ways can a committee of 5 members be selected such that at least 3 members are women? Yeah. So he has given a condition, at least 3 women, at least 3 members are women. Okay, at least 3 members are women. Guys, whenever this is the condition, at least 3 members are women implies that there could be 3 women or 4 women or 5 women. Okay, so these are the conditions. When 3 women are there, how many men will be there? 2 men. When there are 4 women will be there, 1 man. When there are 5 women will be there, 0 men. Yes or no? So when this is the conditions, total how many men are there? 5 men. How many women are there? 6 women. So you can say here, 5C2 into 6C3, or you can say here 5C1 into 6C4. Okay, the last case is what? Guys? Out of 6 women, I am selecting only 5 women. So R means what? Plus. So calculate this. So if you calculate this, you are going to get how much you are going to get? 6 into 5 into 4 by 3 factorial into 5 into 4 by 2 factorial plus 6 into 5 into 4 into 3 by 4 factorial into 5 by 1 factorial plus 6 into 5 into 4 into 3 into 2 by 5 factorial. So if you calculate this, 20 into 10 plus 15 into 5 plus 6. So if you calculate this, you will get 281. Okay, because 3 factorial means 6. 6 will be gone. 5 4 the 20. 2 factorial means what? 2. 2 2s are gone. So 5 2s are what? 10. Okay, so 4 factorial means what? 24. 6 4 the 24. So 5 and 3 will left. So 5 3 is what? 15. 5 factorial by 1 factorial. That will give you 5 only. So 5 factorial means 5 4 3 2 will be gone. No, this will be gone. So you left with only 6. 5 factorial means this. So 4 factorial means 6 and 4 will be gone. 2 factorial means you left with 3. Okay, 3 factorial and 6 will be gone. That's how you know. So 20 into 10 will be 200. So 200, 15 5 is 75 plus 6. So 281 is going to be your answer. Okay, 281 is going to be your answer. Okay, you know, this is how you know you need to select the people. Okay, you need to select the people. Then how to select, you know, the objects. Okay, how to select the objects. Okay, you know, selecting any number of objects. You know, in certain situation, you know, one has, you know, now siding, selecting any of objects. Okay, selecting any of objects. You know, in certain situations, one has the liberty of selecting any number of objects from, say, n given objects. You know, in this case, one can select one object or two objects or three objects and so on, or select n objects. Just as one could have selected n objects, one could also have selected none objects, which means zero objects. Further, if the n objects are all different objects, then not just how many are to be selected, but a further question of which object selected also assume important. Those, there are two cases, the n objects being distinct or being identical. Okay, you know, let's say selecting any number from n objects. So that is nothing but it can be selected NC0, NC1, NC2, NC3, NCN. Okay. So whenever you come across those, the number of which is 2 power n objects. Okay. So the number of objects that can be selected is 2 power n minus 1. Why minus 1? If nothing is selected also one way of selecting. No, so that's why I'm subtracting minus 1. Okay, that's why I'm subtracting minus 1. Let's say, write down a question. You know, you will understand with this question. A buffet dinner consists of 5 different dishes. In how many ways can one help oneself if he has to take at least one dish? Okay, there are 5 different dishes. Okay, there are 5 different dishes. So how many ways he can select? You know, you can write, he can select 1, or he can select 2, up to he can select 5, C5, which means, you know, a person himself select 1 or 2 or 3 or 4 or all 5. Okay, further, you know, when he takes 1, he can also choose with the dish can be, you know, he can also choose which of the dish he takes, yes or no. So which means 5C1, 5C2, 5C3, that is nothing but 2 power 5 minus 1, which means the total number of ways is what? 31 ways. Okay, the total number of ways is what, guys, here? 31 ways. Okay, the total number of ways is going to be what? 31 ways. Okay, so when there are group question, selecting any number from n identical objects. Okay, identical objects. Let's say in how many different ways can a person make a purchase from fruit seller who has 5 mangoes, 8 apples, 10 oranges left with him, and if the person has to purchase at least one mango, at least one apple, at least one orange. So whenever there is a at least, so each type has, at least means, so there is 5 ways and 8 ways and 10 ways, which means 80 and 5. So there are 400 ways will come. Whenever there is a at least situation will come, at least one fruit. Okay, at least one fruit means one fruit will one apple he can purchase, one mango he can purchase, one orange also he can purchase. Since at least one of each type has to be purchased, the number of ways with each of them different fruits, 5 ways, 8 ways and 10 ways, those, the total number of ways in which purchase can be made is 5 into 8 into 10. That's how you can get your answer. Okay, that's how you can get your answer. Okay, so this is, we encounter, the distribution questions. Okay, while, arranging 8 people in a 8 chairs, it is also a question similar to distributing people among chairs. However, this topic is characterized into two distinct features. Okay, usually the number of objects to be distributed are for more than the number of people boxes. Example, distribute 8 chocolates among 3 children. And more importantly, each box person can receive more than one object. No. So which term is important? Let's say, write down a question. In how many ways can 8 chocolates to be distributed among 3 children such that each can get any number of chocolates? Okay, any number of chocolates. Let's look at here. The first chocolate can be given in 3 ways, no? Yes or no? The first chocolate can be given in how many ways? 3 ways. The second chocolate also given in how many ways? 3 ways. The third also given how many ways? 3 ways. Yes or no? Yes or like that there are 8 chocolates. So every chocolate has 3 ways. The second chocolate also 3. The third one also 3. The fourth one also 3. The fifth one also 3. Which means 3 power 8. Yes or no? Which means what? 3 power 8. Always you will get a doubt 3 power 8 or 8 power 3. Okay, but trust me, answer here is what? 3 power 8. Okay, when to use 3 power 8, when to use 3 power 8 power 3 is important. Please remember that even the most intelligent person does make this silly error. So the suggestion is to speak out the entire these sentences. First chocolate in 3 ways, second in 3 ways, hence 3 into 3 into 3. In your mind before committing to answer. So the above reasoning is with the perspective of what happens to each chocolate. First, chocolates can be 3 ways. Few students do have a doubt about Why don't we solve the problems from the perspective of a child? That the child can receive chocolate in 8 ways. No, the second chocolate will be in some Y ways, and so on, different approaches. So, in how many ways can the first child receive chocolates? So, if your answer is 8 ways, think again. If your reasoning is that he could get one chocolate or two chocolate or all 8 chocolates, and he could not get zero chocolates. So, should the answer be 9 ways? Yes or no? So if I put zero, the answer is what? 9 ways. Are you getting my point? Because one or two or three or four or zero. So should the answer is what? 9 ways. But 9 ways is the answer? Not really. So remember that chocolates are different. So the child getting one chocolate is not just one way, and which chocolate he gets also matter. Well, this can also distinct chocolates. Okay, this also distinct chocolates. Those he can get receive chocolates in 2 power 8. If the first child get 0 chocolates, the second child get 2 power 8. If the first child get 1 chocolate, the second child get 2 power 7, and so on. And so on, such that if the first child gets 7 chocolates, the second child can get chocolates in just 2 ways. And lastly, if the last child get 8 chocolates, the second child can get chocolates in only one way, which means no chocolates. Those we would have to use the case of R, because the number of ways of the second child receiving chocolates is different for each case for the first receiving chocolates. Okay, so the problem get compounded for the third child, as the number of ways he gets the chocolates dependent on both of what the first gets and what the second gets. Okay, so that's why 3 power 8. You know, in how many ways 8 letters to be posted in 8 letter boxes? The first letter can be posted in 8 ways. The second letter can be posted in 8 ways, and so on. So the straightforward answer is 8 power 8. But you will get a doubt. When is the answer 8 factorial and when is the 8 power 8? When 8 people have to arrange in 8 chairs, then the answer is 8 factorial. In this case, each chair can accommodate only one person. When 8 letters have to be posted in 8 post boxes, then the answer is 8 power 8. In this case, the letter box can be accommodated any number of letters. Okay, any number of letters. Okay, so this is how you can say that the distribution of the objects. Okay, so the distribution of the objects. Okay, so if we let me summarize this particular topic. We have seen NPR and NCR. What is NPR? N factorial by n minus r factorial. What is NCR? N factorial by n minus r factorial into r factorial. Okay, so how to calculate NPR and NCR? You know that thing. Okay, so guys, you need to understand in this whole particular thing permutation and combination. Okay, permutation, which means arrangement, combination, which means selection. Okay, selection is very easy, but if you want to arrange, first you need to select and you need to arrange. So whenever you're thinking of permutations and combination, You should think of AND rule and OR rule. AND means multiplication, OR means addition. Okay, so we have solved so many questions based on numbers, based on arranging the people, based on arranging the words of a letter when they are repeating the letters. Okay, and we have seen, the arrangement of circular arrangement, why we are getting n minus 1 factorial. Okay, so we have seen all this stuff. So my point is this, friends, whenever you come across permutation and combination, okay, so remember how to calculate NCR and how to calculate NPR and so on. Okay, so what is NPN and what is NCN? Okay, you can write NCR equals to NCN minus R also. How that will come, I have explained you clearly. Okay, I have explained you clear. So whenever, if there are R rule and R rule, okay, if there are M ways, further there are N ways, you can say it as M into N ways. Okay, M into N ways. Yeah, the number of ways selecting one or more items of given items is what? 2 power n minus 1. Okay, 2 power n minus 1. These are the points we have discussed. Why we are getting n minus 1 factorial? I have explained you clearly. There are 4 persons. For the first person, there is only one way. For the next person, it may be opposite, left or right. So for that particular person, if there are 4 places, it is only 3 ways. Okay, so like that, you have to, you have to come across how the selection will come, how the arrangement will come. Okay, okay, yeah. So please decide after reading the question, decide whether this question is the application of arrangement or selection. Sorry, it's a application of arrangement of selection, which means it's application of permutation or combination. Okay, once you know that, the job is very easy. Okay, once you know that, the job is very easy. Lastly, we'll talk about some dearrangement kind of stuff. Guys, please write down. Suppose there are n letters and n corresponding addressed envelopes. Okay, the number of ways, the number of ways placing letters into the envelope such that no letter is placed in its corresponding envelope. Okay, in corresponding envelope. This is called dearrangement. Okay, this is called dearrangement. So dearrangement of n particular objects is, okay, so please write down n factorial into 1 minus 1 by 2 1 factorial 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial and so on, plus minus 1 power n into 1 by n factorial. Now we'll talk about, let's say n is equals to 3. So what you're going to do, 3 factorial into 1 minus 1 factorial plus 1 minus 2 factorial minus 1 minus 3 factorial. So this is 6. So 1 minus 1 plus 1 by 2 factorial 2 minus 1 by 6. Okay, so 6 into, this is going to be cancelled. So 6 is the LCM. Okay, 6 is the LCM. Yeah. So if you calculate this, so 1 by 2 minus 1 by 6. So 6 is LCM 2 how many times? 3 times. 3 minus 1 by 6 into 6. Okay, so 6 going to be cancelled. 6 minus 1 is what? 2. Okay, 6 minus 1 is what, guys? 2. Okay, 6 minus 1 is what? 2. This is how you can endure dearrangement. So we have discussed all the varieties of problems. So this is the end of permutation and combination, guys. Thanks a lot for being in my session. Have a great day. Thank you.